Let's look at a couple of examples of applying differentiation to find the gradient or the slope of a function. So we're told that this function has that form there, and we need to find the gradient of the curve when x equals 2. Well, to find the gradient, of course, we're going to have to differentiate it. So if y is 2x cubed minus 5x squared plus 4 dy dx, differentiating y with respect to x, is going to be 3 times 2, which is 6. The x stays there. The 3 reduces by 1. 2 times negative 5 is negative 10. X and the plus 4 disappears. So that's our function for finding the gradient for any value of x. And now we're going to substitute x equals 2 in there. So wherever there's an x, we're going to put in 2. So it's going to be 6 times 2 squared minus 10 times 2. So 2 squared is 4. 4 times 6 is 24. Minus 20 is 4. So the gradient when x equals 2 is 4. 4 over 1, really, if you want to be technical about it. Okay, let's see if that's true. So let's paste in that function. So this is the function given here, and here is 2. And as you see there, yep, the function is indeed about 4. For every 1 that goes across, it's going to go up by 4. That's why we do it. And notice if we did it, say x is a half, we're going to have a negative slope there. This is the only real way of finding the slope for some functions. Same thing with another curve. So the gradient of the curve when x equals 1. So here is the graph of this curve here. What do we have to do to find the gradient? We'll have to differentiate it. So dy dx of this thing here, the 4 is going to come out the front, so 4 times 3 is 12x, and 4 minus 1 is 3. 2 times negative 2 is negative 4x to the power of 1, and the 7 disappears. What do we do then? Well, we substitute x equals 1 into this equation. So 12 times 1 cubed minus 4 times 1. Well, 1 cubed is 1, so 12 minus 4 is 8. And if we see here, this is when x equals 1 here. And where it crosses, let's actually change the color. The gradient is going to be 8 over 1. So for every 1 that goes across, it's going to go up by 8. It's just the gradient. To find the actual tangent, the actual equation of that line, well, I mean, we know by the looks of it, it's at that point 1, 8, and we know that the gradient at that point is 8. So if we have y minus y1 equals mx minus x1, it's going to be y minus 8 equals 8x minus 1. So y is going to be equal to 8x minus 8 plus 8, so that's just going to be 8x. And if you follow this down, it will, by the looks of it, go through the origin point and be the line y equals 8x. Okay, that's pretty much it for those two. Let's do one more, I think. So we're told that the curve is given by this equation, and we need to find the equation of the tangent at this point. All right, so first off, we need to find the gradient because y minus y1 is mx minus x1. We need to find this one first. We've got y1, that's going to be at -4. We've got x1, that's going to be at 2. So we need to differentiate this. So if y is x cubed minus 5x squared plus 4 dy dx, which is m, is going to be 3 times 1 is 3x, and 3 loses 1 becomes 2, minus 2 times 5 is minus 10, x to the power of 1, and that will annihilate, it will become 0. Then we have to put x equals 2 in there. So 3 times 2 squared minus 10 times 2. 2 squared is 4. That's going to be 12 minus 20. So that's going to be minus 8. So m therefore is going to be minus 8. So y minus 4. So it's going to be plus 4, isn't it? Minus minus plus 4 equals minus 8 x minus 2. So y is going to be negative 8x, bringing this 8 across, minus 6. That is the equation of the tangent at that point. Just as an aside, if you're going to go and graph this, I just tested it a wee while ago, and that point isn't on there, but we're going to sort of make out that it is. That would be the tangent there. That's a straight line with gradient of -8 and crossing the y-axis at -6.